Good day, my angels. Here are the solutions for Lesson 4, Series and Parallel Circuits. So this is really the meat and potatoes of what we're doing. Full disclosure, I love solving circuits. I find them like little Sudoku puzzles, kind of addictive. So I apologize in advance if I'm overly enthusiastic. Number 1 says find all unknown voltages and currents. Okay, well, normally I would try and see if, well, remember the steps for solving circuits. Step 1, label downhill. Can do that. Step 2, try and find the total current. I don't see current anywhere. Step 3, do I know two things? No. Step 4, ski. This is 60 volts. These three will add to 60 volts. Step 5, rewrite them in simplest form. So these three resistors are in series. Our total is really 6 plus 10 plus 8. Our total is 24. I total is going to be V total over R total. It's going to be 60 divided by 24, divided by 6, divided by 6. I get 10 over 4, divided by 2, 5 over 2, 2.5 amps. Now that I know the total current, this question is going to fall apart. So leaving the battery, I have 2.5 amps, which means I have 2.5 amps there, 2.5 amps there, and 2.5 amps there. Knock, knock. I know two things. I also know the voltage. 6 times 2.5 is going to be 15 volts. 10 times 2.5 is going to be 25 volts. Now I could either go 60 volts minus 15, 45, minus 25, 20, and so I could subtract my way by skiing and say that's 20 volts, or I could go 8 times 2.5, which is also 20 volts. They didn't ask me to find the power use now, but now I could go V times I, and I could find how many watts of power each one of these little resistors is using. Number 2. Looks like number 2 is really similar to question number 1. We have resistors in series. So, label downhill. By the way, this is which way the current flows, which is which way positives would flow if they could. This is which way the electrons flow. Electrons would flow counterclockwise in this circuit. Current is defined as flowing clockwise because I hope you'll agree with me now, it does make the math way easier. Step 2, try and look for total current, don't know it. Step 3, look for two things, don't have that. Step 4, ski, doesn't do me any good. Step 5, our total is going to be 2 plus 8 plus 10 is 20 ohms. So I total equals V total over R total. It's 120 divided by 20. Hey, Dan, I'll bet you I can do that in my head, Daniel. 120 divided by I total 6 amps. This question's going to fall apart because now I have 6 amps leaving the battery. There's 6 amps going through here, which also means this is I times R, 12 volts. There's 6 amps going through here, which also means this must be 48 volts. And then I could either go 120, take away 12, take away 48 to give me the 60 volts here, or I could say, you know what, this is 6 amps, it's going to be 60 volts. Number 3. These are so much fun. Oh, ooh, they gave me current. This question's going to fall apart. It says find all unknown voltages, currents, and resistances. Label downhill. Well, 8 amps, so that must mean this is 8 amps. So that must mean that this is 8 amps. Knock, knock. I know two things. I can tell you the resistance. R is V over I. So it's going to be 20 divided by 8, which is the same as 10 divided by 4, 5 divided by 2. This is 2.5 ohms. Here, knock, knock. I know two things. V equals I times R, so it's going to be 40 volts. I'm starting with 100 volts. I lose 20 volts. I lose 40 volts. Well, that's a total of 60. This has to be 40 volts, which also means this has to be 5 ohms, 40 divided by 8. I didn't even bother finding total resistance this time, although I guess I could have maybe, but didn't need to. Number 4. Which resistors are in series? So if resistors are in series, that means there are no junctions between them. So definitely these two are in series with each other. These two are in series with each other. These two are not, because there's a junction between them. These two are not, there's a junction. These two are not, there's a junction between those two. Number 6, ooh, parallel, parallel, cool. Number 6, step 1, label downhill. So that way is downhill, 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 downhill. Step 2, find total current. I don't see amps anywhere. Step 3, ski. Well, this particular circuit has 3 ski runs. This one, and this one. So if I ski this inner one here, I start with 120 volts. Whee! Just going through that resistor was able to get me to the bottom of the chairlift battery. I have to lose 120 volts. By the way, knock, knock, I know two things. The current going through here, I must be V over R. It must be 12 amps. I did that in my head, Brendan. Here's another ski run, and again, I gain 120 volts. Whee! You know what? I must lose 120 volts going through this circuit too. Knock, knock. I know two things. 120 divided by 15. Do that one in your head, Mr. Dewick. Well, okay. 120 divided by 5 is going to be 24. So it's 24 over 3. I think it's 8 amps. I can do the same thing in this outer run here. I gain 120 volts. Whee! And that gets me to the bottom. Now, this bugs some students because some students say, Mr. Dewick, this circuit has 360 volts from a 120 volt battery. No, it doesn't. Every closed loop that leads back to the battery only uses up 120 volts. And remember what voltage is. It's joules per coulomb. Now, this circuit will bleed this battery dry faster because this battery is supplying energy per coulomb to 3 different resistors, but we're not violating the laws of physics. Oh, and by the way, I know 2 things here, so I can tell you that current is 4 amps, and I can tell you the total current because I got 4 amps here, 8 amps here, 12 amps here, and they all joined together. I can say that I total must be 12 plus 8 plus 4, 24 amps. Which is a pretty high current, by the way. Your household plugs only take 15 amps. This battery, remember, amps is coulombs per second. This battery is getting drained pretty fast. if it was a battery. Now, 120 volts, it's probably a power outlet, although a power outlet can't handle 24 amps, but maybe this is a special circuit, a 30 amp circuit. You have a couple of 30 amp circuits in your house. Also, some trailers or boats have 30 amp circuits. I think I skipped number 7. Number 8. Alrighty. Label downhill. This is really similar to the question we just did, in that I can go whee through the 100-watt resistor. I can tell you that this has to be using 120 volts. This has to be using 120 volts. And this has to be using 120 volts. And now I know two things. This time they gave me power. Power is V times I. So I is going to be power divided by V. It's going to be 100 divided by 120. I'll use a calculator for that. I think it's going to be, is it going to be 8.3 repeating? 0.83. I think I got my decimal in the wrong place. Yeah, it's got to be less than 1. 100 divided by 120. 0.8333. I could also find the resistance if I wanted to. Here it's going to be P over V. It's going to be 800 divided by 120, 6.6 repeating. And here it's going to be 200 divided by 120, 1.6 repeating. If you want I total, the total current would be 0.8333 plus 6.6 repeating plus answer button. Total current this thing is using is about 9.17 amps. I don't think I asked for total current, so whatever. Didn't need to find it. Oh, these are so much fun, Mr. Dewick. Yes, they are. Let's do some more. Ooh, in number 8, find the total current if we make the following changes and indicate yes or no. You know what? I'm going to copy number 8 again. Actually, instead of copying the whole thing, let's just copy the circuit part. Alrighty. And now let's copy number 9. Number 9A says, if we add another 100-watt light in parallel. Oh. Let's see. So if we added another 100-watt light in parallel, that would give us one more 100-watt resistor with 120 volts. And so the current would be 100 watts divided by 120, 8.33. So let's list these. We already had, I total would be 0.833 plus 6.67 plus 1.67 plus another 0.833, which is times 2 plus 6.6 plus 1.6. Yeah. 10 amps. No, it wouldn't trip the breaker yet. What about B? Removing the 800-watt microwave. Well, first of all, the obvious answer, if it didn't trip the breaker with the microwave, it's not going to trip the breaker without the microwave. But I guess if I do a quick resketch, I would have this 120 volts. I still have 100 watt and 200 watt. 100 watt, 200. I'm just doing a rough sketch. I'm not doing a proper circuit diagram because I'm just crunching some numbers here. And so I know that it's 120 volts, 120 volts. So I total would be 100 over 120 plus 200 over 120, which is 300 over 120. 100 over 120 plus 200 over 120, which is 2.5 amps. Nope, still wouldn't trip the breaker. You're not going to trip the breaker by removing something. You're only going to trip the breaker by adding something. Adding. C. Okay. Okay. Well, let's bring this circuit back. Copy. Paste. But now we're adding, okay, let's shrink this down a little bit. We're adding a 1400 watt hair dryer. Now this is still 120 volts, and so the current in this is going to be 1400 divided by 120. Ooh boy. 1400 over 120, which is 11.7 amps. This was 0.833, no? Yeah, this was 0.833 amps. This was 6.67 amps. This was, what was it? 1.67 amps. I total equals 0.833 plus 6.67 plus 1.67 plus answer button. Ooh, 20.8 amps. Yes, this will trip the breaker. Now, if you pulled out the microwave, if you shut off the microwave, then you're okay. Minus 6.67. Yep, then you're just under 15 amps. You're close, but you can run that. D. Adding another 300 watt computer in parallel. Okay. Well, again, let's bring in the circuit. We're going to add a 300 watt computer. It's going to put us over. It's going to be close. 120 volts. I is going to be 300 over 120. .5. I think we're okay because it was 0.833 amps, 6.67 amps. What was this one? 1.67 amps. I total is going to be 0.833 plus 6.67 plus 1.67 plus 2.5, 11.7 amps. No, we won't blow the breaker yet. Number 10. What is the maximum number of the following in a house circuit? Okay. Well, 100-watt light bulbs, a single 100-watt light bulb would take power equals V times I, so I equals P over V, which is going to be 100 divided by 120, which is 0.833, and then 15 amps divided by 0.833. How many will blow the breaker? 18. In fact, 18 would trip the breaker, so technically 17 bulbs is what you can handle. How many 250-watt TVs? Ooh, good question. I is going to be 250 divided by 120. 2.083 repeating. That's one TV. And then 15 amps is what we can handle, divided by 2.083. 7.2, so 7 TVs. Oh, and then I got a second B. I should fix that. Oops. Here, let's call this part C. C, how many 10-watt toothbrushes? I is going to be 10 divided by 120, which is not going to be a very big number. 0.083 for each one. 15 amps divided by 0.083. How many electric toothbrushes could it be run? I'm guessing a fair number. 180? Holy smokes. I get 180 would technically blow the breaker, so technically 179. So up here, really, I should change this to 17. D. 800-watt toaster. Probably, I'd be surprised if you can run 2. 800 divided by 120. Maybe you can. I doubt you'll be able to run 3, though. Toasters take a lot of power. 6.67. 15 divided by 6.67. Yeah, you can run 2 toasters. Next one, number 11. Which resistors are in parallel? So parallel resistors start and end at the same voltage. I think of it as the skiers split up and meet up. These two are in parallel because the skiers, the current, splits up right here, meets up right here. Some skiers go this way, some skiers go this way. It also means that these two resistors would have the same voltage drop in them. Okay? What else is in parallel? These two are not in parallel because although the skiers split up, they don't meet up at the bottom of these two until way down here, and there's other stuff in there. However, these two are in parallel because the skiers go this way or this way, they split up, and they all meet up at the bottom. So if this was 12 volts, this would be 12 volts. Number 14. What happened to number 12 and 13? I skipped them because I'm so nice. If you add a resistor in parallel, what happens to the total resistance? Well, let's just make up an example. Let's suppose we have two resistors in parallel. Let's suppose we have, well, let's make it a 10 ohm. Let's go like this. Suppose we have a 10, where's my ohm symbol? Have I got one? Hey, I do. And 15 ohm in parallel. Then our total equals well, 1 over R total equals 1 over 10 plus 1 over 15, and then take the reciprocal. So 10 reciprocal plus 15 reciprocal equals reciprocal 6. So that is 6 ohms. Now add a 5 ohm resistor. Then we would have this. 1 over R total equals 1 over 10 plus 1 over 15 plus 1 over 5. Ten reciprocal plus 15 reciprocal plus 5 reciprocal reciprocal. Ooh, 2.73. You know what? Makes it smaller. And I'll give you another hint. Not only does it make it smaller, our total for a parallel set of resistors will always be smaller than the smallest resistor in the question. So I knew that the answer would be smaller than 5. If instead of a 5 ohm resistor, I'd added a 2 ohm resistor, I'm telling you our total will be less than 2. If I go 10 reciprocal plus 15 reciprocal plus 2 reciprocal, told you. So there's a bit of a built-in error check there. You can survive without that, but it's kind of handy. Can you prove it? I did a numerical example, which actually isn't a proof, but it can be proven if you really want to. Ooh, number 15. I'm going to have to make this a bit smaller to get it on one page. What is the power dissipated? I think this is the first circuit that I'm going to have to rewrite. I mean, that's downhill. But there's no current anywhere. There's no two things. Skiing won't help because it's 80 volts minus, I don't know. I'm going to have to rewrite this. So the first thing that I'm going to find is 1 over R parallel, which is going to be 1 over 12 plus 1 over 8. R parallel equals 12 reciprocal plus 8 reciprocal equals that. Okay, 4.8 ohms. So this circuit can be rewritten as 80 volt battery, a 4.8 ohm resistor, and then a 10 ohm resistor, and then a 12 ohm resistor. That's the mathematical equivalent to the original circuit. And now I can tell you, since these are all in series, our total is just going to be 12 plus 10 plus 4.8. Our total is going to be 26.8 ohms. And that means that I total is going to be V total over R total. It's going to be 80 divided by 26.8, which is probably not going to work out nice, but I'll just store it on my calculator. 80 divided by 26.8. And I get 2.985. I'll go 2.9851. So I guess I have 2.9851 amps going through there and 2.9851 amps going through there. Here it splits up. But I think that's enough because I know two things. At the top there, I can tell you that the voltage is 12 times that, which is 35.821 volts. And the voltage here is I times R. I can multiply by 10 in my head. The voltage here, you know what? I'll call it V1 for R1 and V2 for R2. That's clever. 29.851 volts. And that means now I can ski. I start with 80 volts. I'll lose the same voltage going through either of those resistors, and then I lose 29.851, and I lose 35.821. Okay, I can figure out what I must lose in the 12 and the 8 ohm resistor. It's going to be 80 minus that number, minus 29.851. That leaves me with 14.3281 volts. 14.3281 volts and 14.3281 volts. They want me to find the power here, so I'm done. Now I can go power. Let's go to black, Mr. Dewick. I can say here, power equals V squared over, I could find the current, but I got voltage, I got R, there's a power formula for that. It's going to be that squared over R, and I get 25.7 watts. What did the question say that the answer was? 26 watts. There you go. Ta-da! There you are, and I also hope you have a wonderful, wonderful long weekend.